Hi guys. So I decided to record this video again because I feel like I was not organized in the way I set up my information. Although I did solve the problem, I think I could have done it in a very much organized fashion, and that's what I'll try to do right now. Okay? Let's get right to it. This one says, to win a game, a place kicker must kick a football from a point 19 meters, which is about 21 yards, from the goal, and the ball must clear the crossbar, which is 3.05 meters high. When kicked, the ball leaves the ground with a speed of 15 meters per second at an angle of 51.8 degrees from the horizontal. The acceleration of gravity is 9.8 meters per second squared. By how much vertical distance does the ball clear the crossbar? Answer in units of meters. So obviously, as the title shows, this is a projectile motion problem, and we know that a projectile is an object, which we call the projectile, which is subject to gravity, acceleration due to gravity. Okay? What I'd like to do, the very first step that I like to take is to draw a sketch, or in class we called it a two-dimensional map, right? A two-dimensional map. Let me move. There you go. And I'm not going to try to draw the football. I'm just going to draw like a little dot. And that's the football. Okay? And let's draw the velocity vector. Now, this would be about 45 degrees. So it's more than 45, it's about 51. So maybe that. Let me fix it so it's aligned as best as I can with the football. There you go. Okay, there's the football over here, and that's our initial velocity. And we have the field, right, which is represented by the horizontal, or better said, the horizontal is represented by the field. So like that, right, there's the field. And we know that the football, when kicked, it was kicked at an angle of 51.8 degrees. Okay. Now we can kind of trace the trajectory, right? So I'm kind of like this. Not exactly, but of course I'm doing my best. And that is more or less how the trajectory would look like. And this over here would be the highest point. The highest point is very important in projectile motion. Okay? Then we have to draw the crossbar. I'm going to use purple for that because why not? And the crossbar is 3.05 meters, right? This is the crossbar. And what we need to find is the vertical distance. That is this distance over here by which the football clears. Oh no, that's not good. Let me try it by hand. So we want to see this distance from here to here. We want to know what that distance is. And we'll call this one vertical distance, V sub d. Okay? And there we go. That's all the information that we have. We know that, again, the projectile is subject to gravity. And let's the next step would be to list or write down everything you know about the x direction, then everything we know about the y direction. And then we can write everything we know which pertains to both x and y. I'll explain right now. Let's start with the x direction. It tends to be the simpler one. I'll use green. So x direction. Okay, what do we know? Let's highlight with green everything we know about the x. Well, we know that the football, from a point 19 meters from the goal. Okay, so then we have 19 meters. So if the goal's over here, this is the goal, right? And we can use that one. So 19 meters. Let's take this as our initial position, x. Uh-oh. This is x naught. We'll label it as 0 meters, right? And then the crossbar is, let me move the x direction a little bit more. The crossbar is 19 meters. So over here, this point, right here, this point will be our x final, which is 19 meters. So then the range from the our initial position to the final position, so the range would be from here to here. This is the range, right? That is 19 meters, because we know that to find range, or delta x, now we call delta x the range, we take the difference from final and initial positions along the x. So that'll be -19 meters minus 0 meters. So delta x will be 19 meters. The range is 19 meters. Okay. So range is equal to 19 meters. Let's see what else we know about the x. Oh, I said I was going to highlight, right? So 19 meters. And then, well, from the goal. That's important. Then we have the crossbar, but that's vertical. That's along the y, so no. Now the 15 meters per second, the speed, we can't use it like that for x, because that speed, as you can see, or this vector, right? So the magnitude would be the speed, so the length of this vector. So this vector v naught, initial velocity, has a component along the x as it moves to the right, and along the y because it moves up as well. So we can't use 15 meters like that. We'll have to do some physics and mathematics, as I guess is more mathematics, to find the velocity. And that is, I think, everything we know, right, about x. Well, we know there's no acceleration along the x. Jesus. We know there's no acceleration along the x. That'd be 0 meters per second squared. Therefore, the velocity along the x is constant, which means, or which can be stated as initial velocity along the x, v naught x, is equal to final velocity along the x, vx. All right, and that's pretty much all we know about the x. Now, let's talk about the y, and for that, I'll use blue. Okay, so now, well, the crossbar, the height of the crossbar, it's important because that's along the y, right? So the football has to go past the crossbar, it has to clear, and the distance by which it clears is what we need to find. Okay, we also know that the acceleration of gravity, the acts, or the gravity moves, or not moves, but it accelerates objects along the y direction. And we need to find by how much vertical distance. That's the question, right? Vertical distance, so we have to use an equation from our y direction to solve this problem. Okay, so now let's write things down. Y direction. Okay. So we have that the crossbar, so I'm going to call it the height of the crossbar, is 3.05 meters. We also have the acceleration of gravity, which is, now for this one I'm going to write negative 9.8 because I want to show that it has a negative direction. But when I use it for my equations, I will not have the negative there. You'll see why. And then we need to find the vertical distance, right? So I'm going to call it v sub d. That's the vertical distance. Oh, this was height of crossbar. Height of crossbar. And then this is the vertical distance. That's what we need to find. Vertical distance. Okay. And that is, again, pretty much all we know along the y direction. That's not a lot, but it's okay. Let's see, what about both, right? What do we know about both directions? Which is to say, which variables are not strictly connected to one direction or the other. Time is one of them, right? Time is independent of direction. But we don't know the time, right? So maybe we can find it. Also, the angle theta, it pertains to the velocity, and this velocity is moving along the x and along the y. So that pertains to both. So v naught is equal to 15? Yes, 15 meters per second. 15 meters per second. And theta is 51.8 degrees. Okay, so now what we need to do is we should find the components of the velocity. We should decompose this vector v into its components, right? Because it's moving along the x and along the y. So I'm going to retrace this vector. I'm going to make it a little bit bigger just so the sketch is easier to work with. So this would be 45 degrees, so this is about 51. We'll call this one v naught. And this velocity has an x component, which moves along the x direction like this. There you go. And it also, and we call this one v naught x, right? It's the initial component of velocity along the x. And it also moves along the y, because the football goes up. There you go, about maybe a little bit more, maybe a little bit more. That's good. And that's the velocity initial along the y. Although this is the right way to draw this vector, right, to decompose, I do not like to do it this way because I know I can retrace this vector. I can move it, kind of like move it in space, as long as I don't change it, right? And maybe some of you will see the triangle, and we can connect v naught x and v naught y using head to tail method, right? Like this. That way, the resultant vector is v naught, because that's what's happening. Because when I combine v naught x plus v naught y, I get this one by head to tail method. Okay, and we'll label this one v naught y. This way, it's much easier to recognize the right triangle. Here we have the 90-degree angle, and our angle theta would be this one. We have theta, a right triangle. You guys know we have to use trig, and I know it's your favorite. I'm not gonna do the trig. I'm not gonna solve for v naught y, v naught x. That was part of the notes from last class. But it's so simple, right? Because if you want to solve for v naught y, it's the opposite side of theta, and then we have the hypotenuse, which is 15. So hypotenuse opposite, that's the cosine. So after a little bit of trig, v naught y is equal to v naught sine theta. And v naught x, that's adjacent side of theta, hypotenuse, which means we would use the cosine. So v naught x is equal to v naught cosine theta. There you go. I'm going to move my sketch or this part a bit more. And guys, this is how you find components of velocity, okay? Using trig. All right, let's find v naught x. So v naught x is equal to v naught cosine of theta. So we just plug in our numbers. V naught x is equal to v naught, which is 15 meters per second, right? That's the initial velocity along both directions, times the cosine of 51.8 degrees. And I need more space. I always do this, guys. I always do this. And let's go for decimals. Decimals. Oh, that's not the way. Sorry. There you go. That's what I meant. So let's go for decimals. Let's find the velocity. Let me make this bigger. Let's find the velocity along the x. So that's 15 times the cosine of 51.8. Make sure you are on degree mode, right? Degrees, not radians. So you have 9.276, which I'll round to 9.28. So the velocity along the x initial is 9.28 meters per second. V naught x is equal to 9.28 meters per second. And it's positive because the football is moving, all throughout the motion, right? Always to the right, so it's always positive. Okay, so now let's find the initial velocity along the y. Initial velocity along the y would be v naught times the sine of theta. So v naught y is equal to 15 meters per second times the sine of 51.8 degrees. Let's go back to decimals. We'll do the same thing, but now with the cosine. With the sine. Parentheses 15 times the, I guess I like cosine more than sine. 51.8. There you go. Our velocity along the y initial is 11.787, so 11.79 meters per second. Here's a question for you guys. Is this velocity positive or negative? Let's see. Well, we're using, so it'll be the football moving up from here to here. So if you just think of the vertical movement is just from here to here. It goes up. Therefore, it is positive. It is positive. All right. So now we have both velocities from each component. The question is, can we find time? If you can, please do so. It's always good to have time, because if you look at our kinematic equations, so time, these two don't have any time. But we probably don't want to do that, because we want to find the height. Everything's going to be based on the height of the football. If you look on the x direction, we have a lot less equation and simpler, right? So if we look at this one says range is equal to initial velocity along the x multiplied by time. Now I do have the range from the initial position of the football to the crossbar, and I do have the initial velocity, so we can find time using this one. Once we have time, because time is independent of direction, I can use this time here. Wherever equation I want to use that has time, even though we found time using x, we can use it for y. So let's find time. So range is equal to v naught x multiplied by t. It is very simple to solve for t. We just divide by v naught x. V naught x. It cancels. Time is equal to range divided by initial component of the velocity along the x. So what we're finding, guys, is the time it takes the football to move from this point to this point. Okay? So we're going to find the time it takes to go from here to here. All right. So let's plug in our numbers. Time is equal to 19 meters was the range, divided by v naught x 9.28 meters per second. Let's go to decimals. Let's see what that number is. So it'll be 19 divided by 9.28. Okay, 9.28, and we have 2.047, so I will round to 2.05. 2.05 meters Not sorry, meters, not seconds, right? Seconds. Okay. How can we use this time? Well, think about it, guys. This is the time it took the football to move horizontally from here to here, which means 2.05 seconds is the time it takes the football to move vertically from here to here. This is the maximum height. That's how you find the maximum height, okay? So we can use this time, 2.05 seconds, because we know 2.05 seconds is the time it took not only to move from this original position to the crossbar horizontally, but also from this point here on the ground to the highest point, okay? Clearing the crossbar. So then we need to find delta y max. So how can we find maximum height? Let's go back to our kinematics. So, well, not this one because it's free fall, although we kind of, would be able to use it, but in this case we don't want to because we don't want to use v naught, we don't use v naught y. Look at this one, number 2. Delta y, that is height, right? Some height is equal to v naught y multiplied by t, and then we have minus 1/2 gt squared. So if I use the 2.05 seconds here and here, this delta y will come up to be equal to the maximum height because it takes 2.05 seconds for the football to reach the maximum height. So that's the one we will use. So delta y is equal to v naught y t minus 1/2 gt squared. So now we just plug in our numbers. Delta y is equal to v naught y, which was 11.79 meters per second, multiplied by the time, which is 2.05 seconds, minus 1/2 9.8 meters per second squared. If you're asking, why didn't you put the negative here? Well, because this negative, here guys, this negative tells me that the direction of acceleration will be negative, okay? This negative sign for my kinematics, because if you recall the kinematic equations we had for one direction, they had plus, right? Plus 1/2 at squared, plus. But this negative tells me that down direction is negative. Okay, so there's no need for me to add a negative here because this negative kinda sort of belongs to g, okay, to acceleration due to gravity. That's why if you have a negative here, do not put a negative for acceleration. Okay, and then 2.05 seconds, and then we square that one. Okay, let's go to decimals again. So we'll have 11.79 times 2.05 seconds minus 1/2 times 9.8 times 2.05 parentheses squared. So we have 3.577, which I will round to 3.58. Okay, 3.58. That's the maximum height. So delta y equals 3.58 meters. Okay, positive because it's the maximum height at the highest point. Okay, so now I will add this over here to show that from here, I know it's not exactly right, but I cannot, or I shouldn't. It'd be correct for me to do this, but then it's hard to see. So, I'm going to move this one here. We know this is delta y. We also know the height of the crossbar, which is 3.05. So how can we find this vertical distance by which the football clears the crossbar? But that's simply the difference between maximum height, or this height, delta y, and the crossbar. That's how we find the vertical distance, VD. Now that I think about it, it looks like velocity. So let's change it up, right? Sorry. So I'm going to say distance vertical, dV. Distance vertical. Okay. So let's find the distance vertical distance. That would be the difference between the height, which was reached in 2.05 seconds, minus the height of the crossbar. That's how we can find vertical distance. So vertical distance is equal to 3.58 meters minus 3.05 meters, which is the height of the crossbar. And we can do this mentally, right? No need for decimals this time. That'll be 0.53 meters. And that, guys, is the answer. So this distance over here is 0.53 meters. Okay, that is it. Don't forget, projectile motion problems. Draw a sketch. List everything you know about the x, everything you know about the y, everything you know about both directions, which is usually time, initial velocity along both directions, and the angle. If possible, find the components of the velocities using trig or these two formulas. Then, if you can't find time, use time for one of the equations on x or y, and then use that time for the other one, and solve for whatever they want you to solve. Alright guys, that's it.